So, where we're at, for the first time in since I've put water in this cell, we're now getting some sort of orangey looking growth. Excuse me. I just want to document this before I move on, because let's turn that on. So we got about 100 volts across the extraction grid, and that's because there is the kickback of the high voltage travelling that path. So via this neon, and the LED blew up, I heard it go pop, so that no longer makes light. Yeah, that's where we're at now. From just making that look tidier. Okay, you can ignore that little leftover tail in there. So that cap over here is, I think it's a 200 volt. Let me go around the other side and show you the specs. Yeah, 200. So the other side, there's no signal diode anymore either. That's out of the circuit. So across this, we've managed to build up a pretty hefty voltage. Let me just show you that now. .83 volts DC across that, which is a fair wallop of power. I wouldn't want to touch that. I've tried yesterday, it got to about 36 volts, and I of course tried to run it off itself. The next thing I'd like to try is trying to isolate the cell even more, because that's the cell, that's what the cell is seeing right there, and it's, yeah, not even 10 volts, 2 volts per division. It's only about 6 across that. So yeah, I want that at least kicking 30 volts. So the idea would be 2 of these, and trigger the middle, or maybe trigger the bottom. Anyway, the idea is to get the high voltage to initiate a flashover, have the DC sitting behind it, and the high voltage will come along, throw a high voltage kick from the collapsing, and initiate that ionization inside the cell, allowing the DC to travel through and then cycling over again. I don't know how it'll play out, but that's the idea. Curiously, that's just got bigger while we were standing here talking. Must be the amount of sun that's hitting the panel. I've lost power altogether. What's going on there? Anyway, that's just a quick update. Thanks for watching.